Dear students, मैं Dr. Sangeeta Sharma, Associate Professor, PG Department of Chemistry, Government Inter College, सीतादेव। आज हम MSc फाइनेंस फिजिकल स्पेशलिटी 9 ए पेपर में यूनिट 4 लिक्विड स्टेट में इंटरमॉलिक्यूलर फोर्सेस के बारे में पढ़ेंगे। In continuation to previous lecture, today we take 6 types of interaction between atoms of liquid which are affect the properties of liquid. Force bind the molecules together, that is occurring between the molecules, are called as intermolecular forces. 6 types of attractions are: first, dipole-dipole interaction, that is also known as orientation effect. The molecules which have permanent dipole moment such as HCl, ammonia, water molecule, etc. attract each other by electrostatic attraction. The orientation of molecular dipole is such that the ends of similar charge are as far apart as possible and ends of opposite charge are close to each other. These interactions are significant even at reasonable large distance. The interaction is also one of factor influencing the melting point and boiling point of polar substances. The substances have zero dipole will naturally have lower melting point and boiling point than a polar substance. The potential energy due to dipole-dipole interaction is given by U is equal to minus 2 U raised to 4 upon 3 R raised to 6 kT, where U is equal to dipole moment, R is distance of separation of dipoles, and K is Boltzmann constant. This force is reasonable for crystal lattice energy of substance which must be overcome in the vaporization process. Second is dipole-induced dipole interaction, also known as inductive effect. This type of interaction takes place when a polar molecule is brought in contact of a neutral molecule. The dipole of the polar molecule disturbs the electron cloud of neutral molecules, thereby inducing a polarity in the neutral molecule. This molecule is then said to be induced dipole, which is shown in this figure. The potential energy due to this force is U is equal to minus 2 alpha U square upon R raised to 6, where alpha is polarizability of permanent dipole. It has some dependence on distance as dipole-dipole interaction and usually much smaller magnitude. Since alpha is less than mu square upon 3 kT for molecules with an appreciable moment. For these reasons, polar and non-polar liquid are often immiscible. Third is instantaneous dipole-induced dipole interaction or dispersion effect, explained by F. London. The non-polar molecules also exert weak attractive force on each other. The boiling point of non-polar substances are much lower than those of polar, one of comparable molecular weight. The non-polar atom or molecule is in its fact an oscillating system of electrically charged and has at any instant a small electric moment which varies with time in such a fashion that the moment is zero. This moment induces an opposite moment in the nearby molecule or atom, result in a small attractive force called dispersion or London force, responsible for van der Waals attraction in gas. The potential energy U is equal to minus 3h mu alpha square upon 4r raised to 6, where mu is the frequency of oscillations of the charge cloud and alpha is the polarizability of the atom. The fourth is ion dipole interaction. The negative end of the dipole is attract to cation and positive end is attract to anion. The potential arising from these type of interaction depend upon the relative orientation of the dipole and charge of the ion. The potential energy U is equal to minus E mu upon R, where E is the charge of the ion. But this arrangement is not ordinarily achieved as opposed by the thermal motion. Ion dipole force are important in solvation process. The solubility of ionic solid in water is due to large part to the fact that energy resulting from the interaction between the dissolved ion and the dipolar water is comparable to that of crystal lattice. When KCl or NaCl dissolves in water, positive pole of water surrounds chloride ion and the negative pole surrounds the potassium or sodium ion. This way, the electrostatic lines of force between potassium or sodium and chloride ion are broken and the ion gets hydrated and go into the body of solvent. Ion-induced dipole interaction. The energy of interaction of ions with a non-polar molecule is U is equal to minus alpha E upon 2r raised to 4. It is a weaker and short range attraction. This energy of interaction cannot supply the energy required to dissolve an ionic substance. Thus, such substances are not readily soluble in non-polar solvent. All above forces are referred as van der Waals forces. Sixth is overlap repulsion force. At very short range, a repulsive force due to overlap of electron cloud set of any two ion or atom or molecule. The overlap repulsive force is responsible for steeply rising of the potential energy curve at shorter distance of separation. The energy is U equal to K R reciprocal of N, where N is equal to 9 to 12 molecules. Net potential energy of interaction between two non-polar atoms is U is equal to A R raised to reciprocal minus 6, which is known as attraction force, plus V R reciprocal of N, known as repulsive force.